Hi everyone. Now let's discuss topic 4 of Unit 3, Enterprise Security Architecture. Enterprise Security Architecture, ESA, is a structured framework that helps organizations align their IT security with business goals. It provides a blueprint for securing systems, processes, and technologies across the enterprise. In simple words, ESA acts like a security roadmap, guiding how policies, standards, and controls should be applied to protect information while supporting business objectives. It ensures security is not just a technical add-on, but an integral part of business planning. Some commonly used frameworks in ESA include SABSA, TOGAF, and ZACMAN, which help organizations design and implement security in a systematic way. Security policies, risk management, and governance play an important role in ESA. To make this clear, let's look at some exam-focused questions. 2-mark questions. Define enterprise security architecture. List any 2 objectives of enterprise security architecture. What is the role of security policies in enterprise security architecture? Name 2 security frameworks used in enterprise security architecture. Mention any 2 benefits of enterprise security architecture. 10-mark questions. Explain the concept and scope of enterprise security architecture with examples. Describe the key components of enterprise security architecture. Discuss various security frameworks such as SABSA, TOGAF, and ZACMAN in detail. Explain how enterprise security architecture integrates with business goals. Illustrate the layers of enterprise security architecture with a neat diagram. Enterprise security architecture, ESA, is a structured approach in cybersecurity that focuses on integrating security into every layer of an organization's IT environment. Instead of treating security as a separate component that is added later, ESA makes sure that security is part of the overall design, planning, and functioning of systems, applications, and networks. The main goal of ESA is to align security with business objectives so that the organization can operate smoothly while protecting its digital assets. For example, when a company designs a new online banking application, ESA ensures that security measures such as encryption, user authentication, and fraud detection are planned and built into the system from the very beginning, rather than being added after the app is launched. The objectives of enterprise security architecture are very important for safeguarding information and ensuring business trust. First, ESA protects the confidentiality, integrity, and availability (CIA) of data. Confidentiality means keeping information private, like protecting customer passwords. Integrity means ensuring information is not altered by unauthorized people, for example, preventing hackers from changing transaction details. And availability means systems remain accessible when needed, like making sure online banking services don't go down due to cyber attacks. Second, ESA helps standardize security policies, guidelines, and processes, ensuring that every department follows the same security rules rather than having different, conflicting approaches. Third, it supports business continuity and disaster recovery, meaning that even if a cyber attack or natural disaster occurs, the organization can quickly recover and continue its operations. For instance, having regular data backups helps a company restore its systems if ransomware strikes. Fourth, ESA helps to reduce risks from internal and external threats by identifying weak points and applying preventive controls like firewalls, access control, and monitoring systems. Finally, it ensures regulatory compliance with standards such as GDPR for data privacy, HIPAA for healthcare data, and PCI DSS for payment card transactions, which is crucial for avoiding legal penalties and building customer trust. Key components of enterprise security architecture. Enterprise security architecture, ESA, is made up of several important components that work together to protect an organization's information and systems. These components ensure that security is not just about using tools, but also about having clear rules, processes, and responsibilities. 1. Security policies. Security policies are high-level rules that describe how security should be handled across the organization. They act like a constitution for security. For example, a policy might state that all employees must use strong passwords and change them every 90 days. Another policy could require that sensitive customer data must always be encrypted. Policies set the direction, but do not explain how to implement them. 2. Standards and guidelines. While policies are broad, standards and guidelines give more specific technical instructions. For example, if the policy says strong passwords must be used, the standard may define that a strong password should have at least 12 characters, include uppercase letters, numbers, and special symbols. Guidelines provide best practices, such as recommending the use of a password manager to store passwords securely. 3. Procedures. Procedures are detailed step-by-step instructions that employees or IT staff follow to carry out tasks securely. For instance, a procedure for incident response may include steps like 1. Identify the security breach. 2. Report it to the security team. 3. Isolate the affected system. And 4. Start recovery. Procedures ensure consistency and make sure that everyone knows exactly what to do in different situations. 4. Technology controls. These are the actual tools and systems used to enforce security. Examples include firewalls that block unauthorized access, intrusion detection systems, IDS, that alert administrators about suspicious activities, antivirus software to stop malware, and encryption to protect sensitive data. For example, when you shop online, encryption, SSL/TLS, ensures your credit card details are safe during transmission. 5. People and roles. Security is not only about machines, it also depends on people. Different roles are responsible for maintaining security. For example, a security manager creates security strategies, IT administrators manage user access, and Security Operations Center, SOC, teams monitor for cyberattacks 24/7. Just like in a cricket team, where each player has a role: batsman, bowler, wicketkeeper. In ESA, every role is important for success. 6. Processes. Processes are ongoing activities that keep the security program running. Examples include incident response, how the organization reacts to attacks, access control, who is allowed to access what, and vulnerability management, regularly checking and fixing weaknesses in systems. For example, in vulnerability management, IT staff may run scanning tools every month to detect outdated software that hackers could exploit, and then patch it immediately. Security architecture frameworks. Security architecture frameworks provide structured methods and guidelines that help organizations design, plan, and implement enterprise security in a systematic way. Instead of addressing security in an ad hoc manner, these frameworks ensure that security is aligned with business goals, IT systems, and organizational processes. 3 commonly used frameworks are SABSA, TOGAF, and the Zachman framework. 1. SABSA, Sherwood Applied Business Security Architecture. SABSA is a risk-driven and business-focused approach to security. It means that, before implementing any security control, the risks to the business are analyzed, and solutions are designed to directly support business objectives. For example, if an e-commerce company identifies the risk of credit card fraud, SABSA will guide the organization to design strong authentication and encryption mechanisms that align with the company's business goal of secure online transactions. The key idea is that security should not just be technical, but it must serve business needs. 2. TOGAF, the Open Group Architecture Framework. TOGAF is one of the most widely used frameworks for enterprise IT planning, and it also integrates security as part of the overall enterprise architecture. It ensures that security is not treated as an afterthought, but built into every layer of the IT system, such as applications, data, and infrastructure. For example, if a university is adopting cloud services for storing student data, TOGAF would guide how to incorporate security measures like access control, cloud compliance, and data encryption as part of the overall IT strategy. Thus, TOGAF links business strategy, IT systems, and security together in a structured way. 3. Zachman Framework. The Zachman Framework provides a structured view of enterprise architecture by classifying it into different layers, like data, applications, technology, and perspectives, such as what, how, who, where, and why. When applied to security, this framework helps organizations see security requirements from multiple viewpoints. For example, The who perspective may define roles and responsibilities for data access, while the how perspective may explain how encryption or firewalls protect the system. Imagine a hospital setting. Zachman helps ensure that doctors, nurses, administrators, and IT staff all have appropriate security controls defined for their role, avoiding confusion or overlap. Layers of enterprise security architecture. The business architecture layer focuses on defining the organization's goals, objectives, and security needs. For example, if a bank wants to launch online services, it must set goals like protecting customer financial data and ensuring secure transactions. This layer ensures that security aligns with overall business priorities. The information architecture layer deals with how data is classified, stored, and accessed. Sensitive information such as medical records, employee salaries, or customer credit card details needs stronger protection, like encryption and restricted access, while general data such as public announcements may have fewer controls. For example, hospitals classify patient data as confidential and enforce strict access policies. The application architecture layer ensures that software applications are designed and deployed securely. This includes applying secure coding practices, authentication systems, like login with multi-factor authentication, and regular testing to find vulnerabilities. For instance, an e-commerce application must protect customer login details and prevent issues like SQL injection attacks. The technology architecture layer covers the infrastructure of the organization, such as networks, servers, databases, and cloud systems. Security here includes firewalls, intrusion detection, VPNs, and cloud access security. For example, a company's office network can be segmented so that HR data is not directly accessible from the guest Wi-Fi. The security architecture layer defines the overall security policies, standards, monitoring, and encryption techniques that support all other layers. For example, the organization might enforce a company-wide policy that all laptops must use disk encryption, and that system logs must be monitored for suspicious activities. Benefits of enterprise security architecture. One of the main benefits of ESA is consistency. It ensures that security measures are applied in the same way across all departments. For example, whether it's the finance team or HR team, everyone follows the same password policy and data protection standards. Another benefit is scalability. As organizations grow, ESA makes it easier to expand security without redesigning everything from scratch. For instance, when a retail company moves from 5 stores to 50 stores, its existing security framework can be extended without much difficulty. ESA also improves risk management and mitigation by identifying risks in each layer: business, data, applications, and technology. Organizations can handle potential threats before they cause serious harm. For example, a company can prepare for ransomware attacks by maintaining secure backups and monitoring unusual file activity. Cost effectiveness is another advantage, since security controls are standardized and planned. Resources like security tools, staff, and training are used efficiently. For example, instead of buying different antivirus software for each department, the company purchases one enterprise-wide solution, reducing cost. Lastly, ESA helps with compliance to laws and regulations. Organizations must follow standards like GDPR, HIPAA, or PCI DSS. Having a structured ESA makes it easier to prove compliance during audits. For example, a hospital can quickly show that patient records are encrypted and access is logged, ensuring it meets HIPAA requirements. Thank you. Please like, share, and subscribe.